So with that, before we actually start talking, Selena, I think we're going to do a poll question.
Yep, that's right.
Perfect. Always on the ball. So, before we even start, what is your main treatment challenge or concern? And you're able to pick a couple. So let's have that open. And obviously I would vote for all of them, but hosts and panelists are not able to do so.
Yeah. Let's give people 5 more seconds. Okay, here's the result.
Perfect. So looks like process optimization is a leading one, along with cost savings. So awesome. We love it when we're thinking about how do we make our better processes better through better information. And then how does that directly tie towards cost savings, or in the case of anaerobic digestion, more biogas production. So with that, I'll share my screen. I'm going to put it into presentation mode. And all right. And with that, I will ask the required question during this time. Can everyone see my screen? Great. And, first and foremost, we care about the environment and making more informed and smarter decisions in treating water and wastewater. And so with that, currently that's difficult. There's fluctuating influent wastewater, biological, challenges, and that leads to, issues at the treatment plant, or in the process that can cost, hundreds of thousands of dollars. And that's because, there are limited tools available, because ultimately, existing and traditional sensors get, covered in biofilm and have biofouling issues and have to be maintained quite often. And we estimate that costs $7,000 a year, and lots of time spent cleaning and waiting for sensor drift. Or you've got this chap dipping a cup into a stream, and it's great for understanding in 5 days that you had an issue, but not great for real-time understanding and information to make decisions based on. So where biofouling causes other methods for getting information to fail, biofouling is actually what makes SENTRY work. So first we'll do a quick overview of what's in the system, and then we'll get into our top 5. So at its heart, we've got 2 flat metal sheets that we prime with a small voltage to receive respired electrons from the biology as it consumes carbon. And so essentially we're providing a real-time monitor to understand the biological health of the incoming, or of the plant to treat the incoming wastewater. It comes as a standard with a panel, NEMA 4X rated for outdoors, 2 probes, SIM card connection, and it's generally plug and play. And then, we typically install in channels or, really anywhere where there's a good flow that's representative of the wastewater or at that current point within the plant or process. And so we've got clear problem statements in a number of areas, and all the way from the collection system to the effluent point. About 85% of deployments start with or include a primary clarifier or headworks type location, because it's a good place to really get a feed forward signal for what's coming into that plant. And so so you can actually make informed decisions about how you're going to treat that wastewater when it comes into the plant. And so, just to sort of cap that part off, it's as water or wastewater flows over the probe, biology is the biology on it's consuming carbon. So if you get a huge slug of BOD, you'll get a lot more food for the biology, and you'll see the signal go up. If there's a dilution event or toxic inhibitor, there's less food available for the biology, or it's less able to consume the available food, and so you'll see a drop in the signal. And so it's really like a heart rate monitor for your ability to treat the incoming wastewater. And one thing we do like to point out is, it is really low maintenance. These are 2 probes duct taped together. They were installed about 18 months apart and then never touched due to COVID. As you can see, they are covered in it, and that's exactly what we want them to be. And about 6 months after the second one was installed, we took a screen grab of the 2 probe signals overlaid onto each other, and that's a week's worth of data. And as you can see, they move in lockstep. Obviously, leaving something untouched for 2 years is not the ideal scenario. We do want clients to visually inspect every quarter, but it's just speaks to the nature of the robust nature of the probes and the signal. And so, with that, it's been a very big year. At this time last year, we had just over 55 installations. And at this point, we're now, across North America, quite far into Europe, quite a bit in Asia, starting to get some work in Brazil. And, our most recent deployment that sort of filled out the map was Australia. And then one day, hopefully Antarctica too, to complete all the continents. So, it's being applied to, biological imbalance, plant optimization, and then also anaerobic digestion. And we'll go through a couple of different projects. So we have sort of a broad mix of projects that we really liked that touch on all of those different points. And so, the specific use cases are really in detecting both, organic loading and toxic shocks. It is feed forward in real time, so you can get a very good understanding and informed decisions for making decisions. And, it allows those, long-term patterns and statistical analysis to really make, good informed decisions based on, day of the week or time of day to a specific plant. And ultimately, it'll help you be a better operator in the future, and or your team operate more effectively in the future. So without further ado, and by the way, each of the people in the top 5 either already has received or will be receiving a SENTRY mug. As this is an award show, so we've got to give out some awards. They're very limited edition, very, very great. They're the most leak-proof ones there are. So if you haven't already gotten yours and you're noted here, don't worry, it's in the mail, or it will be in the mail tomorrow. All right, and without further ado, the first one, and I will hand it over to Alex to talk about this one.
So our first case is perhaps a little bit different than what most of you were maybe expecting, and we'll get back in the plant soon. But our first case looks at freshwater quality monitoring. So we've done a little bit of work with source water, but this case in particular, we're looking at lake health. You can hop to the next slide. So the Lake Cane Restoration Society is a group of citizen scientists who are focused on ensuring that their lake remains swimmable, fishable, and livable. And their goal is to really ensure that the water quality stays strong, stays somewhere where they can really enjoy their lake for the long term. But one of the challenges is that it's in a very, very developed area. So this can have tons of different implications for freshwater lakes, and it's in Florida. So you also have the addition of a lot of algae or swamp type growth that can become a risk factor for those lakes. So they've done a really great job of developing a citizen science program around ensuring that the lake quality remains high and that they have a really good set of data and a really good buy-in from the community about protecting the lake quality. So SENTRY has been a partner with them to work on applying the SENTRY technology to a kind of this new application, which is in that fresh water, not processed water, and trying to understand what the microbial activity, what the carbon content, what that lake quality looks like in a freshwater environment. So you can jump to the next slide. So Lake Kane is in a highly developed area. It also has a number of influent lakes. So it's not stream fed. It's fed by a few different influents, overland runoff, which is obviously a concern when it comes to lake quality. And one of the big concerns is you can see there's a much smaller lake right nearby. It's really almost more of a retention pond for stormwater runoff, and that's called Lake Odell. So one of the big questions that we were trying to answer with the SENTRY deployment is whether or not the influent from Lake Odell was causing any detrimental impacts to the quality of Lake Kane overall and the swimming quality of the lake. So when we deployed the SENTRY system, we deployed very near to that inlet, and then we have deployed a little bit further offshore into more the center of the lake to get a better measure of the general lake health, and then more specifically the water coming in from Lake Odell. You can jump to the next slide. So you can see that they also have a number of manual sampling locations. So they were also collecting data from manual sampling to be able to compare, when the CCR data, when our SENTRY probe is reacting, what are some of the things that it's reacting to in the lake, and also to get a really great picture of the lake health and lake quality overall. And what we were able to find is that not only is the lake impacted by all kinds of different weather events, and it has a really strong daily and seasonal pattern to it, which is to be expected from an outdoor freshwater lake, even in a more stable climate like Florida. But we were also able to find some indication that yes, that Lake Odell water does have an impact on the overall lake health. And so you can jump to the next slide. Obviously, it needs a little bit more research just because there's a lot of different things that impact lake health, and it's got quite a large shoreline. So there could be a bunch of other things that are impacting that SENTRY signal. But what we can do with the information that we've gotten so far is really create that baseline to understand what is the lake's natural cycles, to be able to identify when things deviate from what we might expect from the lake. It also allows us to flag poor water quality times so that swimmers aren't swimming in the lake when the water quality is really poor. Generally, we haven't seen that too often, so that's definitely a great outcome from having the SENTRY. And then another step that it can be taken is to develop some issue-specific interventions. So because we know that some of that impact is coming from Lake Odell, well, instead of thinking of interventions that maybe look at for other places in the lake, we can look specifically at how do we mitigate that incoming stormwater from Lake Odell. And then finally being able to promote those policies in the region that are going to help with other impacts to the lake or with the Lake Odell influent.
Yeah, thank you, Alex. And that's great. And I think, one of the great things about, the success in this, initial deployment is we're now with 4 other lakes in the region, and we're getting a great body of work. And we love our partners down there at the Lake Kane Restoration Society. So Jay, if you're on, thanks. And hope you know. All right. So with that, we're going to move it over to Patrick, to speak about AD monitoring and optimization.
Thank you, John. I'm very much looking forward to this. Do you want to move on the slide? Who controls these slides? Alex, Selena?
It's me.
Fantastic. Okay. Oh, it's you. Okay, fantastic. Okay, so in terms of AD, the SENTRY company, we actually started with monitoring anaerobic digesters. So when we first started our commercial deployments nearly 4 years ago, it was with the anaerobic digestion industry in mind. And that's because certainly high strength, high performing anaerobic digesters require really complex microbial communities to all be working together to take these complex organics, break them down to VFA, short chain, carbon-based molecules, and then for the methanogenic communities to come in and convert those into methane biogas, renewable energy. The challenge is operators who are managing these digesters have little to no information in situ directly from the reactors to actually tell them, oh, wait a second, my biomass is actually struggling or my biomass is doing well. And because of that, they tend to underload their digesters, which means that there's a massive safety factor. And it means that invariably they're just not putting as much food, they're not putting as much organics through their digesters as they could do, which means they're not generating as much biogas as they could be generating. So we looked, we've been installing with digesters, whether it's high rate industrial digesters taking brewery wastewater streams, or whether it's municipal clients in North America who are taking off-site additional supplemental organic streams. They're trying to do co-digestion and blend these into their municipal digesters to boost biogas. We're always looking to work with those clients who are operating digesters that want to have a much better feel for what's coming into their digester, and those especially who are looking to push a little bit more and try and think, okay, well, can I put more food into this? Can I generate a little bit more biogas? So those are the ones we love. Now, with the Bakerview Eco Dairy in Abbotsford in British Columbia, we just have a fantastic partner. So we have Chris Bush there on the right. Chris is certainly one of these visionary type people in the water industry or the renewable bioenergy industry. I traveled out to BC 2 years ago now, pre-pandemic, met Chris, and he showed me what was in effect just an ISO container at a farm. And his vision was, this ISO container and all of the reactors that are inside in this, we're going to use it as a test bed to digitize the anaerobic digestion process. We're going to create reactors in series. We're going to understand the acidogenesis, what's going on in terms of acidogenesis, the pre-treatment, the methane generation reactors, and we're going to get your sensors in each of them, and we're going to profile and digitize as we put food in and different levels of food, what's going to happen through the process. So remarkably exciting. That was 2 years ago. And to be honest, you're never sure if these things are actually going to come through or not. But it's amazing to see it actually happen. So you can see the picture there with Chris in his test-based system, and that's exactly what they're doing. So we literally have duplicate processes running in parallel. They're feeding different feedstocks into these digesters, co-digesting, blending different feedstocks together, and we're providing this digital signal. We're converting that biological activity into a digital signal so they can literally see, as they make these changes, the impact it has through the process. So John, if you want to move forward there, I think we have a few slides on some of the data. Yeah, so and this is just a really nice one, so what we see here is the blue line. The blue line indicates how active the bugs are, how much food they're consuming. So you can see the first load they took, and we've highlighted in red there. It was a feedstock that they had left at the facility for maybe a week. So it wasn't fresh, but they thought, okay, well, it's carbon. It can't change that much over the week where it's just sitting there before putting into these digesters. But then you get to see, oh, actually, it's very different, because the next week they actually took a fresh load of what they thought was the same waste. And you see how it's just completely dramatically different from the biomass, how they are responding to that food. And these then directly link into biogas production. So John, I think the next slide, if you put it up. Perfect. So in this case, basically what we're trying to assess is, okay, well, does this signal align closely with the other metrics that we're really interested in with our process? So you can see here 2 reactors working in parallel. In this case, the blue line on the top is the response from the biomass. from our signal, and the orange is the biogas production. So you can see it's really interesting. A lot of the time, you give bugs more food, they produce more biogas. Now on the bottom left, we have what for us is the really interesting part, when you have biogas changing and the microbial activity not changing. And being able to pick up those is really interesting. Certainly if you have microbial activity going up, but the biogas production going down, that's a massive flag for operators. In this case, we understand that the methanogenic populations are really struggling. That's an alarm for operators to say, okay, well, whatever went into the digester at this time is a worry, because we have base microbes who consume VFA having much more activity. It's indicative of a VFA buildup, acidogenesis in the reactor, and biogas production going down. That's certainly an alarm for operators that would then warrant them making decisions about stopping loading, reducing loading, and that's what we do. So it's digitizing how the bugs are performing in the reactors, correlating it to that key metric, typically biogas production, and really making operators a lot smarter about what's going into their digesters and how they can maximize operations. I think that's a good one, John. Maybe I think that's my last slide. Yeah, cool.
Sorry, yeah, that was your last slide, and I jumped into the next one. So yeah, no, thanks, Pat. That was a great presentation. And then I will lead the chat on our third one, which some of you may have briefly seen when I passed on to the next slide. I got a little bit trigger happy there. And so the next one is near and dear to my heart, mostly because most folks may not know this about me, but I am actually from Kentucky, is the last place I lived in the US. So technically it's close to home for me, even though I do live in Canada. So the city of Frankfurt, now they're a very interesting town because they're sort of they experience something sort of at the extreme end of our most prototypical, use case scenario of, overloading organics from a brewery type thing. And they happen to have one of the largest distilleries, about 150 meters away from the front of their plant. So they get, discharges, and then right away it's hitting them. So there was little to no warning. The plant's got a population of about, or the town's got a population of about 30,000, and really only one industrial loader, and that's the distillery. And they can be sending, huge slugs of BOD, but they also clean their tanks and can send down, caustic, or other toxic chemicals. So there's a lot of variability. So this was installed, and we started flagging, distillery discharges, and they work pretty well with the distillery, so they know when they're having issues, and they have pretty good communication. But there were other issues that they were facing, and so we started finding these unknown spikes pretty quickly. It was within a week of installing. Then they started having a weekly pattern of, every Wednesday there was a huge toxic shock. And what we found was the plant folks started talking with the collection system folks, and they were taking leachate in every Wednesday in one of their lift stations, and also cleaning on Wednesday. So what they were able to do was then start to coordinate that to not, shock the plant when possible, and it enabled them to actually really have a good understanding of what was coming in when, and then engage with stakeholders and their own team to really, at least put less stress on the plant. So it's a great case study for us. And what they were able to do is, better manage their oxidation ditch loading. We were able to identify that, 8 millimeters plus of rain, they're impacted. And so they were able to, make changes based on carbon dosing or HRT, and achieved a 5 to 10% improvement in airflow based on, incoming load versus the outbound. So it's a very exciting one for us. And if ever anyone wants to go visit the plant, it is right next to Buffalo Trace Distillery. So there's 2 fun tours to do. You can pick the order in which you do the tours. With that, we will move on to Tom Williams and presenting the next of the top 5.
Fabulous. Thank you, John. This is a great case study from FC Aqualia in Spain. For those of you who are not familiar with FCC Aqualia, they're a service provider that provides solutions for cleaning wastewater and a number of different processes to the market. So they're slightly different to some of the cases we've heard so far, where the operators have been the owners of the wastewater, and this has been their wastewater they're treating. This is a third party that the wastewater was coming from, and FCC Aqualia were contracted to provide a plant to treat this wastewater. And they didn't really know what was going to be coming down the line. They had no real data or real understanding of what's going on. And this particular installation started just before lockdown as well. So it wasn't like they could be on site the whole time, monitoring and taking samples and understanding what would be happening. First slide, please, John. So this site is in northwest Spain. It was a fish canning factory. And as you can imagine, from a fish canning factory, there's a lot of different fish wastes as the various fishes that come through that. And again, that's not a consistent setup. It's not just one type of fish that they're processing. So there's all sorts in that waste that's coming through, and the water. And the wash down of the tanks. So there was equally disinfectants in there as they prepped the food spaces for the processing of the fish and the canning of the fish. So it's a very horrific water, and you can imagine the smells that come with that. So what they had is, and there's a little diagram here showing the processing instrument, that diagram of what's going on, and they have a feed coming into a buffer tank, a balancing tank, and then going into an anaerobic SBR unit, and they want to get a continuous flow coming out the back of that as it enters the Anamox unit. So that's the 3 parts of the process there. And what they really wanted to track was the reaction time and the behavior of the biology in the anaerobic SBR, so that they could get a nice uniform flow going on to their Anamox. Next slide, please. So this was the beginning of the process, and this is the Christmas just before lockdown, as we're approaching last February. And the first phase was where we initially installed the probes, and this is both probes. We had one probe in the buffer tank, so we could try and understand what feed was coming from the fish waste, and then one probe in the SBR unit, so we could understand the reaction of the biology in that unit and when it was ready to pass on to the next phase. So phase 1, we got some good signal from the unit, and then phase 2, as you see, everything drops off a cliff. And what we didn't factor into, and what the team at Aqualia were very happy to understand, was not a failure in their process, but was actually Christmas lockdown. The fishes were not processed over Christmas. Everybody went home, and everything was washed down with the disinfectant, and everything fell off a cliff. But it meant that early January they were ready to restart, and the Aqualia team, even though they weren't actually in the location, could see exactly what was going on at the plant and make sure that the process was running fine and ready to deal with all this waste at an instant, and sit and see this at their desk in their Aqualia offices, rather than having to send somebody to site. Next slide, please. Okay, this is a little more detail of the second probe in the SBR unit. And as you can see, where we have the rise in the microbial activity is during the feeding phase, where they're dripping in from the buffer tank and feeding the SBR unit. And you get this rapid rise in the microbial activity from phase 1 to phase 2. And then you start to see a little die off at point 3. And this is where the reaction is now complete. The biology has consumed everything that's in there. And we're seeing this drop off as we are ready now. It's to move on to the next phase of the process. And the key for Aqualia was trying to optimize that reaction to make sure that we've peaked and the carbon has been consumed, the biology has done its job, and in the most efficient way that they were saving time. Then they're watching the drop off and they're saying, right, okay, now's the time to pass it on to the next phase of the process.
Tom,
and
can I pause you, Tom?
Yeah,
I love this one. This is such a great one. And it's not just for anaerobic systems, but it's basically anyone who's operating a sequencing batch reactor and wants to actually know in real time and just look at a signal and say, yeah, the sequence is finished. The bugs have eaten everything that's bioavailable. It goes to the next step. So I just really like, and people who are looking to shorten those cycles and not just be guessing. It's just so intuitive and so simple.
Absolutely. And that's the key, because the efficiency of processing that waste and how fast you can push that through the reactor is stored here in real time, and you can see exactly what's going on when the reaction is complete and when you can pass it on to the next phase of the process. And the more efficient you can make that, the better. Excellent. So, and here's a bit more detail of exactly what's going on. So it's a bit of an examination on certain dates around this. And you see here we have 4 blue spikes going on. And the third one along, we have a little dip there in the reaction. And instead of peaking as the other ones do and following a uniform setup, there's a bit of a drop off in the middle there of the reaction. And they were able to grab a couple of samples at this point and found out that there was something inhibiting the reaction there in the process, and they can then take action to avoid that in the future, and get a real-time set of information that gives you that detail and enables you to react quickly and sharply to make sure you don't get a big drop off and you can process it efficiently. The next slide. And here is a bit more of the opposite. Actually, there was actually a prolonged increase over a period of time where there must have been getting a heavy load coming into the batch reactor, which was unexpected because it was overnight. And you see there, it's from 6 a.m. till 6 a.m. the next day that they're getting this long extended increase in microbial activity just at the point where they were expecting it to die off. And being blind to this and being 100 miles away from the actual site, it's invaluable to have this kind of information. And then next slide. And then this is the final slide from me. And this shows you what was going on week to week in the pattern of the factory. And the weekend, Sunday was when washdown happened, and when the whole factory site was washed with disinfectant, and all the water that was going into the batch reactor was full of heavy chemicals, and as you can see, Sunday, Monday, the biological activity dropped off as the cleaning happened over the weekend time. And then as fish was processed by the guys working in the factory through the week, they got a gradual build-up towards the end of the week when they had the most load coming onto the plant. Okay, fabulous, thank you.
I'm sorry, I got ahead of myself again. So thanks, Tom. And just a reminder to everyone to get questions in into the chat or the Q&A function. After the next one, we'll go to a Q&A session. And then feel free to put them in there. I can then ask them to the specific panelist. Next up, we have Tim Truax presenting. I hope this one is near and dear to his heart because he used to be a client, then he retired and joined us. I've never asked Tim how long he's been working in the sector because I don't want to then tell him how old I am. So with that, Tim, I'll pass it over to you to present on the next and final of the top 5.
Great, thanks, John. The city of Bend is located in the high desert of Oregon. It's on the eastern slope of the Cascade Mountains, so it has a very dry climate. This is a major tourist attraction for many people living on the West Coast because it's guaranteed sunshine most days of the year, and there's a large mountains for skiing, so it brings a lot of people to town. Okay, John. The wastewater treatment facility in Bend is a conventional activated sludge facility. It was undergoing expansion to a 4-stage Bardenful process while I was the manager, using IFAS as the aerobic portion of the aeration facility. Treated wastewater from this facility is used for groundwater recharge, and it evaporates as well. The ponds or the lakes that are created there are a major birder attraction because of all the birds that will find the impounded water attractive. As I say, a conventional activated sludge facility. On the far right, you see the screening building. We installed the 2 probes in the splitter structure, which is that hexagonal structure to the right of the primary clarifiers. The other probe went into the effluent launder of the second primary, the middle primary. And the purpose of installing these sensors was to identify when we were getting high strength organic material from the breweries in town. As a major tourist attraction, and because of what Bend is, there are approximately 25 breweries that operate in the city of Bend. None of them have requirements for pretreatment, and so all of the brewery wastewater is discharged into the sanitary sewer system, and so adversely affects the biology of the wastewater plant. This is the picture of the location of the sensor that was placed in the second primary clarifier. We found that it needed a little bit more movement, so we moved this sensor out into the effluent launder and created a backwater so that the sensor was always submerged even during periods of low flow. The population of Bend is approximately 90,000, but the population equivalent of Bend is approximately 140,000, and that's as a result of these 24 plus breweries that are connected. The major problem that we had at this facility was that we had very poor settling. This was due to zooglio bulking. We had selectors, so we didn't have filamentous problems. but we had zooglio bulking, and that required very short detention times, solids retention times. And because this plant had a total nitrogen limit, we struggled with maintaining sufficiently long SRTs to nitrify in the winter months, and sufficiently short solids retention time so that the solids stayed in the secondary clarifiers. Shortly after installing the sensor in May of 2020, we were able to detect brewery discharges. In this case, it happened to be a planned discharge from the major regional brewer that indicated that they had bad beer that they brewed, but which they couldn't sell because of the lockdown that was underway. The normal diurnal pattern is visible on this screen from left to right, and that brewery discharge was picked up. Now, this would not have been detected because the laboratory only operates 3 days a week for monitoring influent BOD. And so that became a significant part of the challenge in operating this facility. We did not know when high strength wastes were coming into the plant, and there was no significant pattern involved. Okay, John. So as a result of installing the SENTRY sensors, we were able to understand when patterns were changing, and we almost always dealt with high strength alarms generated as a result of increasing carbon consumption rate. Strategies that we used to deal with that were to anticipate how much mixed liquor was going to grow as a result of the increasing organic load. And so we would adjust our wasting rate to accommodate the growth that we would expect in the mixed liquor suspended solids. We also have had the ability to change the intermediate mixed liquor recycle rate. As I mentioned, this was a 4-stage Barden flow. And so there was an internal recycle from the aerobic zone back to the anoxic zone. The idea was to increase the mixed liquor recycle rates to return more nitrate to the anoxic zones at the front of the basin when there were these slug loads that came into the facility. That in turn allowed us to increase or decrease the aeration during times of peak or low flows. This also helped with the management of the centrate from the centrifuges or the filtrate from the belt presses. So knowing what was coming into the plant allowed us to operate the plant in a much more efficient way, reducing the amount of air or energy used, and also improving our chances of meeting our total nitrogen limit. And that's it, I think. Thank you.
Awesome. No, thank you, Tim. And folks, feel free to put some questions in the chat or in the question and answer. As the moderator, I guess I get to ask questions on my own. So the first question I ask is I guess one that I'm hoping everyone watching will always ask is, how do I get one in my facility? And the answer is, reach out to us, reach out to in certain regional, depending on what region you are in. We have quite a few manufacturers, representatives, partners around the world. So we can, so reach out to us or reach out to any of these folks, and we're there to assist. And these are the types of problem statements that we work on. These are the ones we love, and we're seeing some very interesting results that are demonstrating clear value, to the environment and to those who are using us. And so I'll skip past the thank you slide, and then I will stop sharing my screen because we can go to question and answers. I guess my first question, and I'll throw this one to Pat.
Uh-oh.
Not to predict 12 months from now, but there's quite a few. You've seen the history of the technology. You created it. What types of clients or types of problem statements do you see being in that top 5 next year?
That's a good question. Wow. Okay, so currently, 85% of our clients are wastewater. Half of those are municipal wastewater, half of those are industrial wastewater. So I think a lot of what we're going to do over the next 12 months is going to be profiling incoming wastewater into these wastewater treatment facilities and providing that digital fingerprint that basically explains to operators how the biomass in their plant is going to respond to this wastewater. And I think that in itself is enough and is remarkably powerful as a data set. And the challenge isn't on us doing more deployments in different places. It's actually working with smart operators and smart process optimization people to develop control algorithms and decision-making that just takes that data and makes it valuable. So if we can show you that, look, this type of rain, you can see it rains this much, this is the impact it has on your plant. We can see the biomass not being able to do their work for 6 hours. Okay, we know that now. What can we do at our plant? Are we doing something with our MLSS? Are we recirculating biomass? Are we protecting biomass? Are we diverting wastewater to different reactors? Are we holding wastewater? So that's what I'm looking forward to over the next 12 months, is learning from our operator clients and understanding those great things that they've done with that information to protect their plant and improve performance.
And I really like that answer because it's rain has a very interesting impact based on flow. But what we've also learned, and I think we're starting to get, we've gotten very smart about it, is it's not just about the flow. It's really about that quality dynamically changing over time. And so the next question, thank you, Isabella. Can we use the SENTRY probe as an equivalent of an ammonia probe to control an aeration plant?
I'll take that one.
Perfect.
So we're a very good complement to back-end ammonia control. If anyone has tried feed-forward ammonia control, they'll recognize that it does not work. It does not work, and it's not a good idea. So if you're doing DO control, we're a complement to that by providing a feed-forward carbon-based signal. If you're doing DO control with back-end ammonia control, we're a very good complement to that as well, because again, we can provide that feed-forward signal that basically shows the dynamic nature of the carbon coming into that reactor, and we can help you guys set those DO set points more appropriately and minimizing the impact of that dynamic organic load change.
Yeah, no, great question. And I'll wait for 30 seconds if there's any other questions. And I'll start a sort of wrap up talk. First off, thanks to everyone for joining. Thanks for the top 5 group for implementing and working with us to get to the heart of not only what their problem statements were, but developing that success criteria up front, and then working through it with us to analyze and understand the true value. And perfect, Isabella, we'll get in touch with you. So thank you for the top 5. Hopefully some of you there out there that are on the call will be in this next year as well. And we look forward to continuing to work with everyone. We're having a lot of fun, and we're helping identify biological health imbalances and making sure that we're treating the wastewater more effectively, because we have better information and can make better decisions. So I we're very excited. If you're at WEFTech, come stop by and see us. And we're looking forward to getting back out there and seeing folks again. So thanks again, and we'll talk soon.
Thanks, John. That was great.
Thank you all.